Are we ready, ladies and gentlemen, or do you need a little more time? Good.
Are you doing this?
I'm starting it.
Number 8.
Yeah, but I feel like 8 and 9 are conflicting, so I'm going with that head.
8 and 9 are conflicting.
It's not working how I want it to work, so I have to look at it again.
What 8 and 9?
This.
I thought 7, 8, 9.
Oh, there's
Remember,
It could just be me, because I feel like I made a mistake. But
Please remember, electronegativity does not include a certain family, but ionization energy does.
okay.
I think so. Maybe.
I'll be there in 1 sec, okay? Maybe 2. I'm slow. Okay, ladies and gentlemen, when I get back, we will begin going through this. Yes, what can I do for you?
I still have this. You know, he did promise you if you die, he won't give you any prize.
Then these guys No. But like I said, I'm gonna use
Someone keeps posting Jesus fan edits on the school story.
All right. Anybody got an idea where the first one goes, ladies and gentlemen? Where the first one goes?
This element is the last family.
Well, I would hope you've already read it, but okay. What's that? All right. This element is in the last family of elements to be discovered because they are inert. Okay, what have I just told you? Okay, so now we're into group 18. We're into a noble gas. Okay? And has electrons in the filling, or I'm sorry, and has electrons in the filling the f orbitals for the first time. Boy, that's terrible English. Sorry. So when do the f's first start filling?
6:30.
Sixth period.
So right on.
So the answer is radon. Now, the F's do exist in the fourth and fifth periods, but they don't start filling until the sixth because we are 2 behind. Questions?
Wait, repeat that again?
There is a difference between when the F's exist and when they fill. The F's exist in the fourth energy level, but they are 2 behind, so they do not start filling until the sixth energy level. Now, the D's do this as well. The D's exist in the third energy level, but they do not start filling until the fourth energy level. So there is a difference between when they exist and when they fill for the D's and the F's. Okay? When do the P's first exist? Second. When do they fill?
Second.
In the second. They don't fall behind like the others do. So they're in the same. So
Wait, so what's the difference between starting and filling?
there's a difference between existing and filling.
So like
The F's are the 4 F's. That means they are in the fourth energy level.
so that means the orbitals
They're-
are present, but the electrons.
They exist, yes, but they don't start actually filling that area until down here in the sixth period. Okay? So they exist, but they are 2 behind. So even though they exist in the fourth, they don't start filling until after the sixth energy level starts. Questions? So that's how we get radon here. Questions? Okay. This element is an unstable linear geometry. What have I just told you? And please don't say you told me it's an unstable linear geometry.
Second.
Either the second
Or
or
second.
17th.
No, not either the second or the 17th.
It's in the second group because it's unstable.
It is in the second group. The 17th might be the element with it. But the central atom is the one that we are talking about being this unstable linear geometry. Yes, it may be with a halogen, or it could be with hydrogen. But when we're talking about the geometry and being stable or unstable, we're talking about that central atom, the one that's in the middle, which means it is the what family?
Alkaline earth metals.
Alkaline earth metals. I just want to make sure we're not doing alkaline earth metals, group 2. Okay? And has the lowest ionization energy in its family. So as a trend, what happens to ionization energy as you go down a family? Does it increase or does it decrease? So therefore, where would you find the lowest ionization energy? At the bottom, at radium. Questions? This element is in the same period as the number of d orbital orientations. Okay, how many d orbital orientations are there? So we're now somewhere in period 5. Okay? And is 1 electron shy of the p orbitals having to doubly fill. If you remember when we talked about p orbitals, there were 3 different orientations or orbitals for the p. The px, the py, the pz. So we fill up 1 electron, 1 electron, 1 electron. Now they are all singly filled. Now if I have to put another electron in, I'm going to have to doubly fill one of these 3. So when are we 1 shy of these starting to doubly fill? When there are only 3 electrons in the p. What family is P3? The nitrogen family. So we already are supposed to be in period 5, and now we are in the nitrogen family. We are where antimony is. Questions? This element is in the last period to use only 3 energy sublevels. What is the last period to use only 3 energy sublevels? In other words, no what yet? No F's. What is the last one that uses S, P's, and D's? The fifth energy level. Here, you have S's, you have D's, you have P's. That's 3 energy levels being used, correct? Okay. And as a -1 ion would be isoelectric to xenon. Iodine. By the way, I don't care about the first part of this question. -1 isoelectric to xenon, there's only one element on the periodic table that as a -1 can be isoelectric to xenon. Right there. Right there, that's the only spot it can be. Because when it loses or gains 1 electron, it looks just like xenon. Questions? Now, those 4 questions, the only thing that is missing compared to your test is giving you a clue that will tell you which element you are placing. The element named for the principal of East High School is the element in the last family of elements to be discovered, blah, blah, blah. That's the only thing that's missing. So now let's try one that would be on your test. The 2 elements named after I've got to do some editing here. Sorry, ladies and gentlemen. The types of intermolecular forces are next to each other, but differ in atomic number by 25. Now, there's only a couple spots where they can differ by 25, even though they are next to each other. What are they? Group 2 and 13. What period? 6 and 7. So either barium and thallium or radium and nihilium. Those are the only 2 spots. The one named for a polar, oh, by the way, what are the 2 types of intermolecular forces?
London dispersion, Van der Waals.
London dispersion and Van der Waals. The one named for polar compounds
Van der Waal,
is man-made,
which has to be nihonium.
which has to be nihonium because that's where the man-made elements start. So that is where Van der Waals would go, which means London dispersion would go here.
So does the man-made elements start there?
The man-made elements start at, well, they actually start down here. But this is, in your periodic table, they start in group 13, period 7. And those last ones all the way out are man-made. Questions? Yes, no, maybe so.
What is the one made for? I don't get that. The one made for.
Hang on. Okay, go ahead. Now I'm ready. Go ahead.
I don't get the.
Well, I've given you 2 clues here, right?
Yeah.
So there's intermolecular forces. That's London dispersion and Van der Waals. So now I have to tell you of the 2, one of them has to go in one of the 2 spots we've established.
Yeah.
Now we said these here and here and here were the 4 places where they can differ by 25. Well, to be a man-made element, those start right here. So now this can't be thallium and barium anymore. It now has to be radium and nihilium. But I still got to tell you which one goes first and which one goes second. So the way I did it is I said the one named after a polar compound, which is Van der Waals forces, because those are the stronger forces because there are polar compounds or lone pairs in them, okay, is the man-made one. That means it has to go right here. Now the other one, which is London dispersion, would have to go right here because they had to be next to each other even though they differ in atomic number by 25. Good. Questions? Okay. So then, ladies and gentlemen, I handed you this. Now, up at the top on that line, please write practice test 1. Because then tomorrow, or sorry, not tomorrow, but on Friday, you will get practice test 2. And you will know which one is which, so that if you want to go back and look at your answers and the clues, you got to know which is which on which side of this, okay? Now, this is the test that I gave you then afterwards. Now, I don't do the part where the element named after the scientist who did the oil drop experiment. the element named for the principal of East High School, the element named for the school you may someday graduate from. Okay? I just simply use alphabet. Element A goes here. Element B goes here. Sorry, my double letters are wrong. Why? One should be capital, one should be lowercase. Sorry.
So is that for all of them?
You don't have to do it that way. I'm just saying I messed it up on here.
Okay. I was
So you can either use two capital letters or you can use a capital and a lowercase for the second one. I don't care. Okay? But what I would do if I were you, I would read these 1 through 37. I would put them in the place you think they go. And I would work through it. You want to work with a partner? You are welcome to. You are going to get 3 of these. By the time the third one is done, you probably should be doing it on your own, but if you want to work together on the first one or the first 2, you are welcome to. Tomorrow, by the end of the hour, ladies and gentlemen, I will go through and we will read the clues together. I will tell you where it goes and why it goes there. And then on Friday, I will give you another one. And you'll have a couple days to work on it. And then on Tuesday, I will give you one more. And you will have a couple days to work on it. And then on Friday, I will give you your final exam. And if you can't do it by then, I don't know if you ever will. Yes.
Do we get these back?
These?
Yeah.
I'm not collecting them.
Oh, okay.
They're yours.
I thought you were. Okay.
Nope. Because to be honest with you, by the end of the hour tomorrow, you're going to have all the answers, the correct answers. You can grade yours and see how you did if you wanted. But you'll definitely have all the correct answers. And again, if you want to use this on your test, you are welcome to. But somebody said to me, so I can use all 3 of these tests? Yes, you may. But now I want you to think about something for a minute. You've got 3 of these. How many periodic tables do you got? Give me a number. What would you say? 2. How many with the trends and other things? 2 or 3 maybe?
Yeah.
So 3, 4, 5, 6, 7. Your notes, the yellow sheet. I don't know, are you reaching an overload capacity there for what you can check? Because you've got to answer about 37 or 40 questions in 90 minutes on the final. But again, if you want to keep these and have them there, absolutely. Please, if it helps you, go ahead. Do you think the question is going to be exactly the same? No, but they're going to be similar to this. That's why I'm giving this to you. Okay? Now, again, if you want to call me over, if you're stuck on one and you want to call me over, I will be more than happy to show you or reason through it with you. But again, at some point, you're going to have to walk on your own with these. Okay? So go to work on them. The time is yours. Questions that you have, I will gladly answer. And hopefully tomorrow when we go through this, you'll have a majority of them correct. But again, ladies and gentlemen, okay. I'm going to tell you right now, number 13 is a dead giveaway question. If you cannot answer number 13, you are really in trouble. Because that is one to me that you should not ever get wrong. And I'll bet you people do. Okay? Now, number 12, you shouldn't get that one wrong. You shouldn't. Okay? Now, number 6, maybe. Number 5, a little bit more difficult. But again, if you listen, if you run into problems, I will help you reason through these. There's none of these clues that I will not explain to you if you want me to. But right now, your time is best spent trying to get through as many of these as you can and go from there. By the way, if you read the part at the top, that is the other reason for the line. It says, the 50 elements of Jupiter, we used to name them for the other planets. Now I just put them practice test 1, 2, and 3. So before they used to be Jupiter, Saturn, and I think I didn't call it Uranus because I figured somebody would laugh at that. So I think we used Neptune or something. Yes, Nadia.
Are the man-made elements just the ones?
The man-made elements are from 113, group 13, period 7, till the end.
It's all the grades.
So
Those are the
it
man-made.
doesn't go upwards. It's just those.
Just those. Just those. Actually, the man-made elements are anything over 92. But on our periodic table, the one that you have, that only takes those gray ones down there in that lower, in group 13 through 18, period 7. Okay? All right, go to work, ladies and gentlemen.
Can we?
You will fall asleep.
No?
Najma says she needs him to be able to see.
Yep. No, you didn't, Mom. Yep.
Hey, don't tell her what she did and didn't.
You did? Nazma, you got this?
Please use one of the first two tables if possible, only because I have stuff set up back there. But yes, that's fine.
Yeah. Why would my son look like you?
So you list element, all this and you, but I don't see you and yeah.
So guess what?
Oh, I
Like
guess
all
it's
the
a
other
fill.
ones.
Okay, it's a fill. I think it might be.
Sometimes I do that, yes.
I figured it was some. I had a fill.
By the way, Declan just brought up a great point. I never tell you on there where to place you, other than I tell you what period it's in. But when you place the other 7 in that period, you has to go in the one spot that's left open. So sometimes you're going to be filling something in the spot that is left open. Okay? And by the way, I would put things next to a period, below a family. I would even write them between 2 elements if you're debating between these 2 spots on the periodic table. So you know where they kind of go. Yes. Most reactive metal and element is there. But please remember, it says it's got to be in this period, so where would be the most reactive metal in period 3? Because it says these elements are in period 3. Where is the most reactive metal in period 3? No, period 3 goes across. You can't be talking higher or lower. So think about this. The closer you get to this, the better the metal or the more reactive the metal will be. Correct. So when you're talking about in the period, we want to be further this way because that's closer to the metal, the most reactive metal. If you're talking about up and down, you want to be further down because then you're closer to that spot. So again, in this period, this is the best metal. Where's the best non-metal?
I got two here.
Again, that's a non-metal because they're not reactive. So that's because non-metals are reactive. It can't be the noble gas.
Number 4. So if it's great here, it either has to gain or lose for electrons. Right?
It's element being a metal are the same thing.
So 1, 2, 3, every it's not an ion plus 2 other ones. Oh, that's 4. And then 1, 2, 3. Oh, there's 4. So this would be the plus or minus 4.
Okay. Ionization energy goes down when you go down. And is it the highest ionization energy of all? Yes, correct. Yes, it goes down as you go down. Think about it this way. Helium is the most highest ionization energy. The further you get away from it, that means it's got to be lower.
It just says
Normally we'll talk about more across
until you
or
are
up and down. Right? But if it's something in this corner is the highest, something in the other.
Just then it gives you what's the upper.
Where you going? Did you ask?
So like that's
What did you ask? When?
Right?
What did I say?
Just shake your head. I need a bathroom.
so like right here across the map.
But ask
Based on the
It says all of these are in this element. They're like
all of these are in
it's
this
most
element.
reactive metal.
All of these are in this element.
Yeah, I know. I asked it.
Oh, yeah.
Well, these are the same color.
So, please understand, ladies and gentlemen,
So,
there is a difference between the highest ionization energy of all and the highest ionization energy in a family or in a period.
because
Okay? Period just means comparing them going across. Family means comparing them going up and down. Highest ionization energy of all means of every element of the periodic table. And that's helium. Okay? But you can talk about the one that has the highest ionization energy in period 3. Or you can talk about the one with the highest ionization energy in group 13. You're talking about in a group that's up near the top. If you're talking about in a period, it's further to the right. Okay? Doesn't mean it's the best of all. It's within that period or that group. It's the best. Away your phone. Please. Thank you.
so F is the most reactive metal, so it has to be a metal.